Hello guys, this is Stefan Persson, also known as Infantia, and I needed to make a gradient sky in Unity, so because I'm going to be making a platformer at some stage pretty soon, I guess. And I didn't want to use a texture, and I didn't want to have to repeat coding this all the time, so I thought I'm going to create just a basic procedural mesh and then map it with a gradient, and I want to try to get it quite efficient and reusable. And so yeah, just let's get started. So the first thing I'm going to do is just create a bit of a tidy project, and I'll be sharing this code later on, so I'll sort it into folders that you can import without any conflicts. So let's start a root folder called Infantia, and then we're going to call the project gradient sky. And in here we want a scripts folder to keep it nice and tidy. And I'm going to be needing a shader for this because I want the vertex shader to colorize the vertices and have that create the gradient rather than using any textures. So first things first, I'm going to create a script. Yeah, let's go ahead and do that. So we're going to be doing a C# script, and I want to call it gradient sky. And let's open that up and delete these. I always like to start from fresh. Okay, so the first thing we're going to do is we want to have a gradient variable. And let's set that to null to begin with. So we can do this at the same time here. Let's create a game object. Let's call that gradient sky, and we can add that component. And as you can see, just by defining this variable here, we get this gradient to play around with. So I want to be using that to define the gradient sky. Okay, so once we have that, let's go back into it. And then we want to be creating a procedural mesh. And basically we want to create a mesh that is a quad, but we want to have vertices so we can have different vertex colors at different heights. So we create a method called createMesh. And then we also want to create a default gradient. So let's create a method as well called createDefaultGradient. And that doesn't need to return anything, so we put void as the for that one. This one's red because it's not returning any mesh yet. So the first thing we want to do is let's have a look. We want to start to creating this mesh. And let's do a float width. And I usually use the naming convention to have an underscore in all my private variables. Yes, you don't have to do that. It's just something I like to do to quickly identify that it's a private variable. Then we need a height. I'm going to be using these as probably static at 1 and then use scaling to resize the object because then that'll make it easier to align with the time variable in the gradient, which is also from 0 to 1. And then let's create a new mesh. And we need to create a bunch of vertices. So let's count how many that will be. So we need to have vertex count equals, and we've got the gradient, and the gradient has color keys. So one key for each color. And that's an array. So we know by the length of that array how many color values there are. And since we want basically like a ladder, you could say, I'll draw actually. Let's do Photoshop here. I want to create something like this. So if we just have any picture, I want to create a mesh that looks like this. So that this will take up the camera, and then I want to have the mesh to create segments like this. So basically, we can have from dark black at the top of maybe the space, and then fade to blue, and then fade to light blue, and then fade to yellow. So that's why we need not just a simple quad, we need to have vertices here and set the colors of those. Because then when you have the colors of these vertices, the GPU and the graphics card will it'll interpolate from that color that's up here in these vertices, and then it'll just do a really nice gradient to this color and then to that color. So that's why I want to do it like this. So the vertex count isn't just 4, we need the length of the array, and then we want to multiply that by 2 because it's a vertex on the left and the right side. And then we need to create a bunch of arrays as well, because when we construct the procedural mesh, we need vertices, normals, UVs, and colors. So let's go ahead and create those. Let's do, first one's going to be a vector 3. And that's for the vertices. So let's define that one. We need the vertex count. That's how large the array needs to be, 1 for each vertex. The next one is the normals. The normals is which direction the normal is facing of the vertex. So that'll be quite straightforward for us they'll all point in the same direction facing the camera. The next thing we need is an array for vector 2s, and that's for the UV mapping. And UVs is basically just a value from 0 to 1 to say where to look on the texture, if there was one. And then let's do a color array, and this is the color value of the vertex. Okay, so we've defined those, and now we need to iterate through the color keys and start creating these vertices, normals, UVs, and colors. So let's do a for loop. Let's do an int I starts at 0, and then as long as I is less than the gradient color keys length, and then we want to increment I by 1 every step. And then let's start to create the vertices now. Each procedural mesh needs to generate these values then. So we do the vertices array, and we do the I value. Okay, so we want to have the I variable, and then, so the first iteration of the loop, that's going to start at 0, and then it's going to go to the first color key and the second color key. And we need 2 vertices on each vertex, so we need to multiply this one by 2, and I'll explain that in a second. And then we'll do a vector 3, and we're going to start at negative width divided by 2, because we want it halfway to the left of the center. So the width divided by 2. That's the x value, or the width. And then for y, we want to do the gradient color keys. And that's an array, remember, so we need to reference it by the I value. And then we want to use the time value, because each color key has got a color value, so a color, and it's got a time value. And the time value is basically on here. It's this value. So whether it's 0 here, 0.5 here, or 1 up here. And remember, in this one, we want to have that value to represent the height, which is going to be the same as the gradient, so the height on the mesh. But then we also, so we've got that value, but we need to also take in consideration the height. So we deduct the height divided by 2 to get halfway up to the top. And then the Z value is going to be 0. We don't need to care about that one. Let's see what this is complaining about. Oh, right. Okay. Can't do a float there. So the next thing, that was the left vertex that we created, and then we want to do the right vertex. So we want to multiply I by 2 as before. I'll explain that again in a second. And then we want to have +1 because if this was vertex 0, the first iteration, this is going to be vertex 1. And we can actually copy a lot of this stuff here because it's going to be very similar. The only difference is that we want to do width divided by 2 instead. So we got from negative on this side, center is here. So we want to do negative width here, and then on the right vertex, we want to have positive width divided by 2. So that's the vertices done. Let's do the normals. Same thing here. We want to do I multiplied by 2. And this is going to be quite straightforward. Or quite the opposite, in fact, because it's going to be negative forward. The reason is that we want to have when we create the object in the default scene, we want it to face towards the camera. And by default, Z is facing away. So if we create this one with the normal facing the opposite way, then it's going to be facing the camera instead. And then same here for the right vertex. And that's going to be the same actually. That normal is going to be facing the same way. Oh yeah, as I was saying, the reason why we have the multiply by 2 here is because if this is the mesh and we have the vertex here, 0, 1, 2, 3, 4, 5, 6, and 7. The first iteration is going to go I is 0. So 0 multiplied by 2 is 0. So that's going to be vertex 0. The right vertex is going to be 0 plus 1. So it's this one and then that one. And the next time around this loop comes around, then I is going to be 1. So 1 multiplied by 2 is this one, 2. 1 multiplied by 2 is 2, plus 1 is going to be 3. So it does this vertex. And then it steps through all the color keys and creates the vertices. And that's why it looks like that. And then we're going to do the UVs in case we need them. And that follows the exact same pattern. All we need to do is here is so we're going to create a new vector 3. And it's going to be 0 because we don't need to care about the X value for the UVs. We only want to care for the height in case we were to map a texture in the future to this. I don't think we'll be needing it, but let's put in for good measure. In case you need to use UVs in some other procedural mesh, maybe it's good to know. Let's have a look. We need the radiant color keys. I time, which is a value between 0 and 1. And the same thing goes for this one. And then finally, let's set the colors as well. I multiplied by 2 equals, and then now let's just grab the color keys value. And that's called color. And it's going to be the same color for the second one. Because we're using the same key for the left and the right vertex. So this sets the color of these vertices. So yeah, that pretty much finishes up building up the arrays. The next thing we're going to do is set them. We need the mesh to actually have these vertices. So let's do the mesh. Vertices equals vertices. There we go. So now we've actually sent this array to the mesh component. And now comes the fun part. We need to actually, so we've created the vertices. Now we need to create the triangles of the procedural mesh, because without the triangles, it's not going to draw anything. And the triangle is going to be so between three vertices. So a triangle is defined by having three vertices. So it'll be, for example, the first triangle is going to be 0 to 1 to 2. So it'll create a triangle from 0 to 1 to 2 and down. The next triangle is going to be 2 to 1 to 3 and then back to 2. And then it'll build all the triangles up like this. And that's required for the procedural mesh to show anything at all. You can't just have like a point cloud with vertices. So let's start by defining the triangles variable, and that's a bunch of integers, because the triangle is just referencing a vertex in the array, in the vertex array. And the number we need is going to be color keys, the length of the color key array, times 6. And why times 6? It's because we need, for each segment, we need 2 triangles, and one triangle consists of 3 vertex indexes. So it's going to be, for a full quad, it's going to be 6 integer references. And then let's loop through. Again, create a for loop here. We want to do color keys. No, not that one. Gradient color keys -1. We were going to go from 0 to not the full length of the vertex of the length, because we want to go to just one below. And let's start defining the triangles. So triangle, I'm going to have I times 6, because we're stepping through this one. And we're going to do multiple iterations of this. So first time around it's going to be 0. And then when I is 1, it's going to start on vertex 6. Or not vertex 6, on index 6. So it'll be 1, 2, 3, 4, 5, 6, and then it's going to start on the next one, the next time it iterates through this. And we're going to be creating 2 triangles at a time in this loop. We want to do I times 2 plus, and for the sake of keeping it understandable, I'll do +0 here, because that just refers to 0 here. The first index, which isn't anything, that's not needed, but since we're going to do a lot of defining, I sometimes like to keep it so that I understand the method of thinking. Let's copy this one. And we're going to need, for the first triangle, we're going to need 3 of them. And this needs to increase each time, because we can't assign it to the same I times 6 here, because then it'll just overwrite the previous value. So we need +1 and +2 here. So again, first iteration, it'll go to, when I is 0, it's going to do in the 0, the first entry, number 0 in the triangles array. And then it's going to do 0 + 1, which is 1. And then it's the second spot in the array here that we're creating. And we want to define the vertices here. And we're actually doing 0 to 1. We do clockwise instead, not like I described before, but we'll do 0 to 2 to 1, and then it'll default back to 0. So from vertex 0 to 2, and then back to 1, and then back to 0 by default. So that was the first quad, and we can just copy this. Sorry, it was the first triangle. And then we can copy this. And we're still in the same for loop here. So we need to do the next slot in the array, which is 3. I guess we can keep it for the sake of keeping it consistent. Could do this as well. So we do 3, 4, and 5, and that fills up the whole first set of 2 triangles here. And for this one, we want to go from vertex 2 to 3 to 1. So we're going to go from vertex 2 to 3, and then 1, and then back to create this second triangle. And next time around, when this loop goes around, I is going to be 1. So 1 times 6 is 6 plus 0. So then it's going to start to continue with the array here. And here we got I times 2, which is 2 plus 0. So it's going to start here instead of there. And then it's going to go 2 plus 2 is 4. So it's going to go up there, draw down there, and then back there. And it'll do the same for the whole mesh, basically. And then we need to send the rest of the arrays to the mesh. So we do triangles, mesh triangles equals the triangles array that we just defined. We want to do mesh normals equals normals. Mesh UV is the UVs, which we may not need probably. Mesh colors equals colors. So there we go. We've created the mesh, and let's return it. This red will go away then, because now we're returning the mesh that it's expecting. Okay, the next thing we want to do is create the actual array. We won't be able to see much yet because we're not calling this method from anywhere, but we also need to think about creating a default array. And by doing that, we need to see we've already created the method there. So I need to define 2 arrays here of gradient color key. Let's name that one gradient color keys. And a gradient also has alpha values, alpha key. So let's create an array for that. We'll always keep those as 1, but we'll still need it. And then let's use the variable that we created, gradient, and then let's create a new gradient. And this is just so we don't start with a white gradient, that we want to have a default gradient. So when you create the object, we want a blue sky to begin with. And then we want to start gradient color keys. And let's create an array size of 3. So we'll do 3 keys rather than just from white to blue. Let's do 3 steps to make it look a bit nicer. So maybe from a very bright blue to a mid blue to a darkish black blue. Let's do the first one, and let's set the color to new color, maybe 0.8, 0.9. We need to do F here for floats. 0.95 maybe. So this is going to be a very white, the RGB values, a lot of red, a little more green, and even more blue to keep it nearly white, but still a slight blue tint to it. And the first key, we want to have the time value set to 0 on that one, because we want to have it at the very left. It's going to be this key that we created here, this one. And then we're going to create a key here now. So let's duplicate these. And let's set this one to 0.5, which is in the middle, and then this one to 1, which is all the way to the right. And then we need to step these up, so it's the first key, second key, and third key, but it starts from 0. And then we need to change these color values a little bit, so it's not just the same color. So we'll do 35 there maybe. And then 70, maybe 99 even there, to keep it nearly, not perfect blue, but very blue and quite bright. And then the last one, we want to fade to quite a dark blue at the very top. So let's do, maybe just keep a little bit of red there anyway. Let's do it very low like that. And then the blue value here, we're going to still have a little bit more of that one, maybe like that. So, and then next thing we need to do is create the alpha keys as well, even though we're just going to keep them at 1. But we'd only need 2 of those, because we're going to keep it from 1 here to 1 over here as well. So let's set alpha to 1 for both of the keys. And then let's set the time value to 0 and 1. And we've done those keys as well. And then we actually, so these are just two new arrays that we've created and filled them with values. Now we actually need to send them to this gradient that we created. We do that by doing gradient, set keys, gradient color. First it's the color keys, then it's the alpha keys. There we go. This will create a default gradient that we need to call at this time this object is created. The next thing we want to do is create, we also need a mesh renderer. So we've created the mesh up here in this method or function, whatever you want to call it. It's the same thing. And now we want to create a mesh renderer, and we're going to want to disable a few things like shadow casting and things like that. So let's create a new method that we called create mesh renderer. I'll be reusing some of this code I plan for later on, so that's why I'm creating methods instead of doing it in a one big, just so I want to create some reusable code here. And let's create a new mesh, or let's define rather a new mesh renderer. Actually, let's require a component here for this one. We want to require a few components up here, because it's going to always need a mesh component and a mesh renderer component. So let's put that here straight away. Require component type of, we need a mesh filter. The mesh filter is what contains the mesh in the end. And we need a mesh renderer. So when we create a component from this, it'll automatically create these components for the game object that's created. So we know that it's already going to be there, so we can also get this component now. So we do just get component mesh renderer. And then we also want to create a material now. And here we're going to need to create a shader, a very simple shader. So that's going to be our next step as well. Let's call, we need to find that shader, and let's call it custom vertex color just. Okay, misspelled that one. There we go. Okay, so this shader doesn't exist yet, so maybe we should actually go ahead and create that one straight away. We created a shader folder, so let's create a shader here. Let's call it vertex color. We don't actually need all of this stuff in it. Ours is going to be a lot simpler than this. We don't need to do separate vertex and fragment shading, so let's keep it extremely tidy. We don't need any properties, I think, but we need a sub shader. I think we can actually keep it extremely empty in the beginning. This will just pass through. We don't need lighting to care. We don't need to care anything about lighting or bump mapping or anything like that. So this is just going to send the stuff to the shader and render it. And we're going to probably want some features here for maybe queuing and things like that later on, and red writing to force it to be in the background. So let's keep it extremely just empty like that. Let's go back in here and continue with a few things. So we want to do, when we add, let's have a look here. Let's delete that one, save it, go back here. Now if we add this component, it should add the mesh renderer and the mesh filter, as we said that it needed. And as you can see here, there are a few features here like cast shadows, receive shadows, and blend probes, and also even light. Yeah, the light probe user. So we want to disable these things so it doesn't cause any problems with, we just want it to render as a static unlit background. So we can start by disabling those in the script here. Let's disable occlusion, dynamic occlusion. And then we want to disable shadow casting mode. We don't want it to receive shadows. And we don't want it to use light probes. And we don't want it to use reflection probes for that. And then finally, we want to set the material that we just created of the mesh renderer. So we've created, we got the mesh render component, we create a material with a custom very simple shader, and we disable a bunch of features on the mesh renderer that we don't want for this background sky. And what we want to do now is when we create the mesh, since we need the color keys from the gradient, and by default there is no gradient, so we want to make sure here that if gradient is null, then we need to define it. So we call create default gradient. It'll go down to this function, execute this one, create the default gradient with the color keys. And then it'll come back here and continue and use those color keys to generate the mesh from those. Okay, so let's go ahead now and create a new method called reset. Reset is called by monobehavior whenever a component is first added or when this reset button is clicked here. So either when you add the component or if this reset button is clicked. And we'll use this one here to first reference the mesh filter. And we haven't actually defined, let's do a variable for that one first here as well. Public mesh filter. We want to keep a reference to this mesh filter so we can access it faster rather than getting the component every time. And in here then we can do mesh filter equals get component mesh filter. This is so we avoid having to get the component in every frame if we need to access anything in it. And also when we make a variable public here, it'll come up here, and we don't ever want to need to assign this manually. This is for the background, so we can hide this in the inspector. The reason why I keep it public rather than private, because if I was to make it private, then it wouldn't show up here. But the problem with when you generate a procedural mesh and you go between edit mode and play mode, Unity does something called serialization. So it needs to recreate basically all the stuff when it sends it to the compiler, I believe. So in this serialization process, if it's a private variable, that won't become persistent. So it needs to either be public, or you can also do with, just for reference, I guess I should mention that you can do, if I were to do this private and call it mesh filter like this, I could also do this serialize field, which will force it to serialize. But by forcing it to serialize, it'll also show up in the inspector, even though it's a private. So it sort of defeats the purpose, I guess. So just to keep not having to have two tags there, I do it as a public variable, so it's automatically serialized. that doesn't make sense, there's a lot of content online if you Google Unity serialization, and it takes your head some time to wrap around it. It's quite difficult maybe to understand the concept of what the serialization does and what it doesn't do, and it took me quite some time to get it straight in my head. I don't know if it fully is yet, but to the point where it is now anyway. So when we hit the reset button, or when the component is added, we get a reference to the component of the mesh filter, and we want to create the mesh at this point as well. And we want to do shared mesh, even though it's just one. We want to not create a new mesh all the time. We want to use the share mesh for the mesh filter. And let's call the method that we did to create the mesh. So when the component is added, it'll get a reference to the mesh filter, and then it'll create the mesh, call the method to create it. And then we also want to create the mesh render that we did down here to ensure that it assigns the correct material and disables the stuff that we didn't want running. And finally, yeah, I think that's pretty much done now. Let's have a look. Let's give it a try. See where we screwed up. So if I delete this component, let's create a new game object altogether. Create empty. Let's call it gradient sky, and let's add the component gradient sky. Okay, so we got some issue here. It did create the gradient like we wanted to, with the values that we said, from bright blue to a mid blue to a dark blue. But we got a, what's that color called? Magenta, colored pink it's called, mesh, and we've got some null reference exception here. So let's have a look. If you double click on this one, you'll send, okay, so we don't find the custom vertex color. And why is that? Let's have a look. It's because it hasn't saved the shader, so it's still got that asterisk there. And I've noticed when oh yeah, so Control S, solve that one. Let's clear it. Let's try this again. Let's remove the components as if it was a brand new object. And let's add the component gradient sky. Okay, we still got a problem. Why is that? It's the same one. Custom vertex color. Ah, that's why. We need to call it the same as we called it. Custom / vertex color. Let's give it another go. Clear the log. Remove the objects. And let's add the component. There we go. Okay, so it's created our mesh here, as you can see. And it's quite small at the moment, but it's a procedurally created mesh. If we select this one and click on the mesh here, we should actually see here that it's got the quads that we mentioned, that we discussed here. So it's generated the vertices and created triangles. And then it's assigned the colors. So the white one's down here, the mid blue is here, and the dark one is up here on those two vertices. And then this is where the GPU does its nice job of just interpolating. We don't need to care about this at all. It does that automatically. So it just fades from that color to the mid color and then to this one. So that's the beautiful thing about this one. And then we don't want to have a small sky like that. And this one can just be scaled. I press the R here to get into the scaling tool, and you can scale it to whatever size you want. And this is just like any Unity game object now. You can position it the way you want, and you can resize it the way you want. And I think by default, let's create so that when it's generated here in the reset, let's make it a little bit bigger straight away. So it's not created as a little tile, because most probably you're gonna want to have it a bit larger anyway. So transfer local scale, new vector 3. Let's make it 20 wide, 10 high, and just the default one. It's gonna be a flat anyway, but let's keep the scale at 1. That won't affect anything regardless of what the Z value would have been. And let's try to create it again. So let's remove these objects here. And then add the component. Yeah, now it creates it a bit bigger like this. So here you go. This is the first step. This is if you want like a static sky like this. To keep in mind here, though, is that if you resize this one to something that you want, maybe you want it extremely wide for a platformer. If we create a game object here, a 3D object, let's call it ground. Let's make it wide and move it down a bit. Let's give it a color as well. Let's just create a temporary. I'll be deleting these later on. That's why I'm not bothering to put them in the folder. So let's call that just green. And set a green color to it. And then maybe we want to have... So if this was a platformer, maybe you'd have a few platforms like this. So when you move the camera in your scene, you'd get quite fast, you'd realize that you reach the top of the gradient, which isn't so good. First of all, we can disable the skybox. We don't need that one. So let's do a solid color and black just for now. So as you jump around on your platformer, okay, fine, it's fine as long as you pan sideways. But when you go up, you're going to run out of sky. So what you could do about that is make it, scale it so it's a lot taller. Like this, for example, and then you have a lot of freedom to move up and down. And if you want to keep it so that you can always adjust the gradient now, we just created a default one. But here you can change this gradient to have a much narrower, let's see if we do this, a narrower band. Come to think of it, actually, this brings us to an important point. As you can see now, I changed the gradient, but nothing happened to this mesh. And it's because we created the mesh based on the color values that it was when the mesh was created. So we need to do the next thing now and make sure that this is updated. The mesh needs to be recreated as you change these values, because we need to change, if you added keys, for example, like I did here, we now know we don't need just three sets of segments. We need 5 instead. So we need to recreate the mesh, detect when that happens, and then recreate the mesh. So to do that, we actually need to start looking in the update function and see if anything's changed. If anything has changed to this gradient, then we need to call a recreation of the mesh. So let's do that. So in the update function, we want to be looking for this. And for performance reasons, we don't want to be checking against the gradient all the time. We want to keep it so we don't have to access the gradient components and the mesh components all the time. I'm going to create a cache value for this instead. And by cache, I just mean a temporary variable that I call cache, and then I assign the gradient values to. And then I'll be able to compare the cached values to the actual values. And if those are not the same, then we need to go and recreate the mesh and then reset the cache flags to say that, okay, these are good now. So let's create another public gradient called cache gradient. And let's hide this one in the inspector as well. For the same reason as before, we don't want to see it, but we want to keep it public so it's serialized and kept between play and edit state. And when the mesh is created now, here in create mesh, before we return the mesh, when everything's finished, we want to set the value of this cache so we have something to compare to. So we set the cache gradient, we create a new gradient, and then we need to copy the values. And we can't do that without having to do this first. We need to do the create an array, a temporary array for the color keys, and then copy these color keys, and then the same for the alpha keys. I have to do this middle step because I can't use this next line. So when I do cache gradient set keys, can't do that unless it's two separate defined arrays like the ones above. I can't just do these two straight away. It won't allow that. So I'll do these two new arrays. But basically that's what happens in the background. It'll take the color keys and the alpha keys, and then I'll put that into the cache gradient. So now we've got the newly created mesh, and we've got the cached gradient here. And now let's start comparing that. So still in here, but in the update in the update method here. First check we could do is if the color key length, so the size of the array of the current gradient, so the one that's actually in here, and the length, remember, is the number of keys. We got 1, 2, 3, 4, 5 now. So if that isn't equal to the cached values, so if the cache has fewer or more keys, then we know that something has changed. And we want to replace the mesh and recreate it by the new one. So basically what this does, if we've added or removed a key from the array, every frame it'll check that and it'll say, okay, the length is different, which is quite a cheap check to do if the length is different. And if it is different, we want to replace the mesh by a newly created mesh, because then it'll go here and then dig into the new gradient colors, rebuild the mesh as necessary, and then it'll set the cache value back. So next time it comes to this loop, it's not going to need to do anything again. Then we're all good. And we also want to return out of update here, because we're going to do more checks now for the actual color values. But if the length is different, we don't need to start comparing in this frame about if the colors have changed, because it's going to recreate the mesh anyway. So the next check we're going to do is actually start looking at the color keys if you've changed the values of the actual colors of the keys. And we do that by doing a for loop again. And then now let's compare them. You can't just check if a color equals a different color. You need to check if the RGB, the red, green, or blue values have changed, which are floats. And you need to see if any of those have changed. You can't just check if color A is equal to color B. And for that, I'm going to create another function or a method. And let's do that on as a bool. It'll return a true or false value. And let's call it is color key approx equal. And then let's create two arguments for this one. Call the color key 1, color key 2. So we want to compare the two color keys, and it's going to be the cached and the true gradient values that we want to check. And to do the check, let's do first see if the time of the key has changed. So if we've moved the key sideways here, let's check if we've moved it anyway. And that's the time variable of the color key. And we can do that by doing color key 1 time minus color key 2 time. And then let's do math ABS, the absolute value. So if we take time of the first key minus time of the second key, and then do that, turn that to an absolute, always a positive number. Then if that is greater than some threshold, let's say 001, return false. Then we want to say this is not equal. This is just a value, because the problem with floats is that if float A is equal to float B, even though you've set them to the same value, 0.15 for example, sometimes it'll return that it's not equal because it'll have some really small fraction at the end, for example, like this. The value that you set to 0.15 might be in fact in Unity like this. And it's the nature of floats that you can never rely that a float is going to be equal to the exact value of the float that you set it. You always have to accommodate for the fact that there'll be a small fraction difference. So if color A was that and color B was like this, even though you set them both to 0.15, it could be like in fact that they're like that, so they equal. If I were to just check if they're equal to each other, that wouldn't work. And this way we just detect if there's a change greater than 0.01, that's when we're going to trigger, and that's why we're doing what could seem maybe as a bit of an odd check, but that's the purpose, or that's the reason why we're doing it this way. So if the if the time has changed, then we return false. We don't need to check anything further because we already know that the color key has changed, so we're going to return true. But then we also need to check if the time is the same, but you've changed some color values. We'll do the same type of operation here, but instead we'll do the red value minus color key 2 red value. If that's greater than 0.01, that means that the red tint was changed. Ooh, it's not capital, it's lowercase r for red. And then return if the red color was changed. We don't need to check anything more, but if it wasn't changed, let's check the green and the green and the blue. And if we've gone through this now and nothing has changed, then we want to return true, because then they are approximately equal. And then we need to spell it correctly. Here we go. So now we've got this method here saying, are they approximately equal? And we started to create this for loop here to compare the color keys. So let's continue with that. So if is approximately equal, and then we do the gradient color key I. That was the first color 1 that we called. And we want to compare it to the cache gradient color keys I. So if they are approximately equal, if they're not, sorry, the exclamation point here, if they're not approximately equal, am I missing a bracket here? Oh yeah, it's a hard bracket there and a parentheses there. There we go. So something has changed, then we want to do mesh filter. What am I doing here? Something's, oh, it's still a parentheses missing here. There we go. So mesh filter shared mesh equals, and then let's create that mesh again. And by creating a new mesh, it'll basically just overwrite the old one, so you don't, the garbage collector will just pick the old one up and throw it to smithereens, because we don't need that one anymore, and that's what the garbage collector does. It takes, if it's not referenced by anything, it'll just bin it. So we don't need to take it away. There we go. And we can also actually do a return here, because if we've detected that any of these keys have changed, for example, this first one, we don't need to check if any other keys have changed, because we already know that we need to recreate the whole mesh. So let's give this a go now. Hopefully it should work. Let's start from the beginning actually. Let's remove the component. Let's add it. So it still works so far. Let's rescale it a bit. And now let's try to change this. And nothing is happening. Oh yeah, and I know exactly why. It's because we are in edit mode now. And by default, Unity doesn't run the update function or the update method in edit mode. So we need to put here execute in edit mode. Here's a good thing to know, that the update isn't called in the editor every frame. It's if you add it in execute in edit mode, it'll only call it if something is changed in the scene or something would affect it, so it needs to redraw. So be aware of that. But for our purpose, it should be fine because we're actually changing the color keys. So now we're saying that that script should be executing when we're in edit mode now here, not just in play mode. And now when we change these values, it'll start to recreate the mesh, as you can see here. Let's do it again. And we can also add for another key, for example, if you wanted to pink tint to the sky. So basically it'll detect, oh, something has changed in the gradient. Let's recreate the mesh, get the colors right, and then update the cache. And we don't have to do that again until, so it's not recreating the mesh every frame now, it's only doing it in case it needs to. And to verify that, I usually do things like this. So if I throw a debug log message here, I usually do this. My code is usually spammed with this thing here. It shouldn't be visible here. If we do stuff like moving the object, it's not visible in the debug log, but as soon as we change here the position, because the time thing triggered, then it triggered the recreation of the mesh, and it did it a few times because I was sliding the key there. So that's something I just do sometimes to ensure that it's not calling it unnecessarily, and we don't want to have it recreating the mesh every frame. That would be performance suicide. Okay, that concludes the first video, which is basically just creating this mesh to act as a game object. And as I mentioned before, if you move the camera key, just make if you move the camera in the scene, just make sure that your game object here is scaled to a size that that you need. And if you need it to be very tall and very wide, but as you can see, it just looks plain blue here now. Maybe you want, I recommend that you create, here's a thing as well. If you move this key now, it'll shrink the mesh because there's no key down here. But you can fix that by just creating a same key of the same value here. So you could compress this whole range here. Oops. Like this. So if you want the main part to actually have the gradient, but you want a really big mesh, you could just compress the whole thing like this. And what that does is you'll have a nice gradient on the main level. But if you want to have maybe someone jumping really, really high and you move the camera up, maybe you want to just transition to a solid blue or even a black or something. You could add, let's do that straight away actually. Let's go from a dark blue to even space. That would be just creating in black there. So as you jump up here, you still got the nice gradient, but you jump up and whoa, you transition all the way into space here and then back down again. So this first video, I was just creating this very simple to create a game object that acts as a sky like any other game object in the scene. And what I'm going to do in the next video is actually going to take and reuse a lot of the code. And then I'm going to create a gradient that's fixed to the camera. So it doesn't matter. Maybe you don't want the sky to move around. Maybe you want that to be fixed. And basically you could throw this gradient sky as a child to the camera, and then it would move. Let's see, if we move the camera, it would move with it all the time. But there's maybe a few reasons why you wouldn't want to do that. It's not so neat to have an object as a child of a camera maybe, and maybe you don't even want to see it in the scene. So I'm going to create a mesh that's scaled and positioned to just always occupy the size of the viewport. And I'll be doing that in the next video, and I'll do some reusable codes. I'll be splitting this code into a script that's inherited. So maybe if you want to learn a little bit about inheritance in C#, you could look for that purpose as well. And so yeah, I hope this helped you. And this is also available in the asset store. I'm going to put this up as a free asset there if you need it. So this video is just to teach you a little bit, well, hopefully teach you about some procedural creation and how this was created. So thanks a lot for watching, and watch the next video if you're interested. And also check out my assets if you can on Infenzia on the asset store. And you can also go to www.infenzia.com and check out all my stuff there. I do a lot of space related things and audio, sound effects, music, and anything gamer related really. So drop over there and feel free to subscribe and like the video. Thanks a lot. Bye.